So I'm going to try to talk you through the lab step by step without taking a lot of extra time to do so. You'll see that on the board behind me, it is a black background, and I'm going to be writing in white because it's hard to see and pick up on the camera. However, as I go through it, all I'm going to be using that for is my data table. I'm going to use that to write down the information that needs to be written down. As you go through the lab, it is important that you wear goggles the entire time, and it will be important that you and your group follow instructions and do the best that you can in terms of being accurate and precise. You will find on each lab station a beaker, 250 milliliter beaker. It may not be clean and it may not be dry. Your job as a group, first and foremost, is to clean and dry this beaker. Then, using one of the grease pencils, it is also called just a glass marker, you're going to somehow identify that this beaker belongs to you and your group. You'll write your name on it. Because these are hard to get off, I am not going to write my name on it, so someone else can use this one. But you're going to write your name on this beaker. After you write your name on the beaker, and it is clean and it is dry, you're going to put it on the digital balance and write down its mass. Its mass should be somewhere around 100 to 120 grams. Mine, my beaker alone, is 109.24 grams. That is my beaker clean and dry, and that's an important number that I'm going to need later. So I've written that down. Secondly, you're going to take your beaker and you're going to add to it, measured approximately as close to 50 milliliters as you can possibly get, of copper 2 chloride solution. It is the blue solution that you will find in a couple of different lab stations. Right now I need to make some more, but it's in this beaker, or in this bottle right here. I'll have more of it around. You're going to take 50 milliliters and you add it to your beaker, your clean and dry beaker that you have labeled with your names on it. So now I have in this my solution. You will then obtain 2 nails. Now these nails are made out of iron. They're magnetic. I guess I should show you that they're magnetic. So we know that they're iron. They stick to my magnet. So they're definitely iron nails. However, I want to make sure that they're relatively clean from any other rust or any other impurities. So at each lab station you'll find some steel wool. The steel wool acts like sandpaper. And what you're going to do is carefully, you're going to rub off any dirt, any excess grime, any protective covering that's on our nail. I haven't done a great job on mine because it's just for demonstration purposes. But you'll put it down on your table and you can rub it, and it will start to have the steel wool will come off and it will leave piles on the table of this little small pieces of steel. Then you'll want to take a rag or a paper towel or something and be sure you wipe up any of that dust. That could cause metal splinters, which are terrible. You don't want to do that. So we've got our nails. There's going to be 2 of them, and you need to find their mass before you start. Once you've cleaned them off, you're going to find the mass of the 2 nails on your digital balance. So for my 2 nails, I have a mass of 4.72 grams. That is going to be important at the very end of our experiment. So I know the mass of my nails, I know the mass of the beaker. It was clean and dry and it has solution inside. I don't care so much about that solution inside in terms of its mass. I know how much I started with, and now I'm going to add the metal nails into my solution carefully. Don't just drop them in so it splashes all over the place, but drop them in gently, maybe even pick it up and let them slide down into the solution. And once they are in there, we're going to sit back and relax and let the reaction take place. We're going to wait about 20 minutes. In class, once you get to this point, everyone's going to stop and we're going to take a break and I'm going to cover some new information. That's going to be really important that you understand what's going on. When we get to the end of this lab, you'll need to know what's going on. So we put that into the solution and we set it aside and we wait 20 minutes. I'm going to hit pause, and then in 20 minutes from now, I'll start it back up again.